Okay, so I'm going to try to do three things in this video. The first thing I want to do is join the arrests data to the incidents, just so we can see kind of a comparison. The second thing is I'm going to try doing a heat map, and then the last thing is I want to show you a plugin that you can use for the time variable if you want to try to create kind of a flipbook of maps. So I think let's just start with the join. It shouldn't take too long. The first thing I want to do is actually, I've got this filter on the data for my May 31st definition, and that's great. I'm going to come back to it. But just so that my join works properly, I'm gonna get rid of that filter so that the join will join to all of my records and not just a query of them. So I'm going to delete that query. And you know what? I'm actually going to just copy that and save it somewhere, because a lot of times it's annoying to have to rewrite all of your queries. And so here's one query, right? This is day in question. And so I'm going to keep that as a query. And as I make more queries, I'll probably end up adding them to this notepad here. So I'm going to delete this now. Got it written down. Okay. And we've got our whole database again. And so now what I want to do is I want to bring in these 2020 arrests, which is a CSV. It's just a table. And before I do the join, I want to open up my shapefile attribute table and open up my arrests table to just identify the key field. So the key field in this one is something I created for you. It's this J, and then this is incident code. And the incident code was included in this original file. I'll show you here. And the number came originally from, it was tagged along the end of a date field, this incident number. And so there's a unique incident ID kind of as a unit of reporting. Sometimes there might be multiple, multiple people involved with any individual incident, but there's usually a unique incident code. And so that links to the arrests. And so what I did for you was I created this join code so that they're all exactly the same length. And I put a J in front of there as a reminder. And that'll talk one-to-one. There should be one of these that relates to an arrest if there was an arrest. And so there's a bunch of different types of joins. We're going to be joining the arrests, which, I mean, we see there's 88,000 records here for the incidents. But there's also, there's probably only about 1,000 or 1,500 arrests. And so those 1,500 arrests, we're going to try to join those to here. But obviously there's going to be some null values, places where there was an incident and then not an arrest. So it's pretty easy to do. All we got to do is go into the properties panel to join for the layer, the shapefile layer that we want to join the table to. Hit the plus sign here, and we've got we want to join 2020 arrests. We want to join by the incident code and then the join code over here. And so those should be exactly the same. You can leave this on. That should be fine. It'll let you kind of use the table immediately if you want to. And then we can choose which fields to join. I think I just want them all to be joined, so I'm going to just leave that. Like if you only want one field, you can just pick it. But if you leave it unchecked, it'll bring them all through. This one is important though. If you don't change this, then it'll create a new field name with this at the beginning, which is going to effectively erase your field names, because most shapefiles, the DBF, which is the table format, won't accept field names that are longer than a certain length. So I always intentionally either just delete it so that my field names, there's no prefix and I'm just going to get these. But sometimes if I'm working with data, I like to remind myself that it was joined, that it came from somewhere else. So I might add like a J or an underscore ahead of it to remind myself that it's a joined field. So I'm going to do J for joined field, and that's going to create a prefix ahead of these fields. So I'm going to say OK. It looks like it says it joined, so let's just go and see. You know, another good thing to do before we go see how it joined, I'm going to open up this table. I see that there are 1,486 records, and let's see how many of them joined. We open the attribute table, and we're going to go and we see, okay, a lot of null values. Hopefully that's not the norm here. Sort descending. Okay, good. The join worked. I'm going to make a selection of everything that was joined so we can see how many actually properly joined. And it looks like of those 1,400, only 1,100 joined. So there's 300 that either something's up. Either my join code is not working properly, or the style of the incident code for the incidents and arrests they're either not correctly entered by the data provider, or perhaps there was an arrest that doesn't relate specifically to an incident in the field. Maybe it was a warranted arrest or something. Though I would imagine that should be reported, I would think, in this incident case reports as well. But anyway, so it worked. So we've got over 1,000 arrests. We would want to make a note that there were 300 of those 1,400 that are not showing up as due diligence of just kind of what data we're actually looking at. But that's cool. So now that we know we have the arrest data joined, we could just start to visualize with it. But it's good practice to save as a new file, because then it'll actually write a table. Right now, this table is a separate file that in the computer's kind of memory it's just connecting them because you've told it to. It says, yep, that's joined to that. If we remove this from our workflow, then that join won't work anymore, and so we couldn't do calculations and things like that. So what we want to do after we do a join is usually we want to export, save the features as a new file, and I'm going to call this 2020 incidents and arrests. So I say OK. That's good. And now if I open up this attribute table, they should still be there, we would hope. And just make sure they didn't fall off for some reason. No, and they're all there. And the great thing about the arrest data that we don't get with the incident data is we do get some of these variables like we talked about, age, sex, race, that kind of thing. So cool. So I think that's interesting. One thing we could do really quick is we could query to see if there are a similar number of arrests. There's supposed to be 53, I believe, in that same evening. So what I might do now is I'm going to copy this style and I'm going to paste it here because this is my new database. And I'm going to get rid of my old file because I don't need it anymore. And I think I'm going to go and do that same query again. So we'll say source query builder. Oops. We want to grab this query for the night in question. Say OK. And now let's say I want to see only places where there was an arrest made as well. What I might do is open up this again, and now we're going to add that it also has to have, let's see, we want it to not be null. So pretty much any definition that is a thing is going to be fine. So there's a whole bunch of different ages. Let's just say age has to be greater than 0. So what that means to me is that at least, you know what, we should test it. Let's test it in a different way. Let's just say we're going to make a selection. That way we can see how many records have an arrest associated with that query. So I could have done that, but it would just create a new kind of filter. But I want to see this filter as well as kind of a sub-selection. So I'm going to leave that filter on and use this tool now to say where the fields, where age, so where there's pretty much any person, where age is greater than 0, select features. And there's only 6 reported, That's interesting. Only 6 reported arrests from that day, it's saying. So let's just go and open up this attribute table and see what's going on. So it looks like, and this is where it's hard for us to tell. Because it is an incident, it's possible that this burglary commercial or one of these variables is really representing maybe a dozen people that, perhaps that are all involved in the same disturbing of the peace, orderly conduct gathering. Even that one alone might constitute the arrests for that day. And that's interesting that it says, yeah, I don't know. They'll have to be, of course, see they've got an age there. So we'd have to investigate more or ask, we'd have to reach out to the department to ask about, where are those 53 arrests? And perhaps it's us misunderstanding how this system works, that we're not seeing 53 arrests and we're only seeing 6. But anyway, those 6, they relate to this specific incidents, so we know that they are related. And we could check that kind of time variable just to make sure, yep, these are all late at night during that same time when the article was talking about the peaceful protest kind of devolving into rioting and violence. And okay, so that's one thing we can do. That's interesting. I hope you look at the arrest data because it does have a lot of things going on that would be useful to see. Looking at the giant point cloud of incidents is one thing, but looking at, for instance, what the distributions are of where arrests are actually happening, what race and age people are that are being arrested. So those types of things, especially in comparison to the other incidents and in comparison to, the town or the city as a whole and the demography, are definitely worthy of investigation. I think what I'd like to do now is show you how to do a heat map. And I know I've kind of derided those throughout the course, but there are certain ways that I think they're useful. And one way is by summarizing an actual number of incidents in kind of a hotspot. And for better or worse, this really, this area where the protest happened, it really was a hotspot that evening, right? There were many, many, many incidents that they tried to record. And one thing you should see is if we kind of zoom into this area, is we might click one of these, and it looks at first like it's one feature. That one might be one feature. Let's just see if we can find another one. That's one feature. Some of them, I believe, are multiple. Yeah, exactly. So there's like 2 on that one. Let's just see here. There's 3 or 4. So in this one spot right here, there's actually multiple. There's 1, 2, 3, 4, 5 instances right in that one spot. And then here's another with 1, 2, 3, 4, 5 incidents as well. So some of these are actually recording kind of multiple things, and it's all that same time frame. But it would be nice to be able to see kind of more of a spatial summary of how many incidents are happening kind of in a unit of area. And so when we don't have a bin, so to speak, we could try to summarize these by parcel boundaries or census blocks, but it wouldn't really work because a lot of them are happening on the street. And so, how do we get these points to fit nicely into a boundary so that then we can then create a summary of how many are happening? So a heat map is kind of a nice way when you have a point cloud to try to demonstrate how much of a thing is happening with that point cloud, and you can kind of create some sums that way. So I think what I want to do just for this, and we're only looking until midnight. I'm sure that on January 1st at 12:01 and 1 a.m. there were also more incidents that we should probably take a peek at. And potentially there's more arrests there as well. But what I'd like to do now is try the heat map tool. So I think if it's not in the raster, you should be able to find it by going to your processing toolbox and typing in heat map. and it says kernel density estimation. And it, the thing that's hard about heat maps is that they have this thing called a kernel density, which if you want to read about it, you can. It's kind of it's pretty abstract to the lay person. So what I'd like to encourage you to do if you're going to make a heat map is use what's called a uniform parameter for a heat map. We're going to decide on a radius, how far away is something related to something else in which they're going to sum. We're going to get a sum. And I'm going to just say, let's do that 400 meter or 406 meter or whatever it was, that quarter mile, right? So that's going to be our radius. That's how far away this window is going to look, right? From any location, any pixel on the raster we create, it's going to add up the number of points that are within a certain distance of that pixel. But what I want to do instead of this, this kind of kernel density, I want to try a uniform version, which is just going to give me a 1 or a 0 and add those depending on whether or not a point is within that search radius. So it might be confusing, but when we get the result, I'll show you what I mean. So I decided, yep, that's the size that I want. This pixel size looks like it's going to be huge, right? This is a pretty 161,000 pixels by 133,000 pixels. I think we can get away with a 1 meter by 1 meter, or even less. That's still pretty high. I'll do 5 meter by 5 meter. That should be okay. Okay, so I'm going to hit run and save it as a temporary file. And now you can kind of see how, just how crazy heat maps are. So what it did is it's got a circle, right? And there's a 1 for everywhere that is within a certain distance of one of those points. So, and it looks wonky, and that's good though, because I think I'm hoping what you see is even when you use the kernel density, it's still based on these points. So these points are meaningful, and we're just interpolating something from them to give us useful information. And the reason we've got so many more in this area is, of course, there's more dots, but there's also more dots or incidents. There's more of them repeated on top of each other. So for instance, this one right here, right? There are look at all of these, right? Here are all incident. They're all stacked on one dot. And so that's why this uniform is saying, well, we told it a quarter mile. Anything within a quarter mile is going to be relevant to that point. The kernel density would kind of feather this out a little bit. But now we're seeing where all those things kind of overlap and intersect. So choosing a smaller distance might be more appropriate for this. But let's symbolize this so we can kind of see where the heat maps where it overlaps. So the best way to try to mess with these rasters is to do a single band PseudoColor or a paletted values. There's 57 is the max and 1 is the minimum. So I'm going to do a single band PseudoColor. And PseudoColor just means that it's going to let me paint values across the pixels. So I think we'll just do it this way. Hit apply. And we can kind of start to see, okay. Yeah, this heat map, I think that this quarter mile is a little too much. It's definitely summing, all these are adding to this one, and that's why we're getting this kind of weird overlap going on. So, you're welcome to try something that's not uniform, but I think it's probably better that we try to stick with uniform and then just create more meaningful distances. So let's say that everything that's within, maybe we could say, 400 meters about a quarter mile, 200 meters is an eighth of a mile. Yeah, why don't we just say everything within 100 meters, that's fine. Everything within 100 meters is related. Let's say if that's in a protest or in a riot, that's a very meaningful distance that you would be affected by it, perhaps. I'm just kind of making this up, but hopefully you can come up with something that makes sense to you. So we're going to do the uniform. If you'd like to try these other ones, you're welcome to, but I'd suggest you kind of read about what they're doing. It might not make sense to you, but it's hard to tell what the values mean if you're not sure. So uniform is very simple. It means a uniform value within a distance of the input. So I'm going to try to run this again with 1/4 of the distance as before. So I think that's going to be, yep, just about a 1/16 of a mile. Run. Okay. And I'm also going to run it at a 1/2 mile, just so you can see the differences between these heat maps here. I think the thing to remember is that a heat map is always going to use some type of searching radius, and then it's going to try to weight the pixels based on whatever's within that searching radius. So for better or worse, even though it doesn't look very good, this uniform is a good way to get to understand how the tool works. So anyway, that's why we're doing it. And the other thing I would do is I'm going to take my symbology here, and I'm going to say copy that style and paste it on these ones. So now we should be able to see, we'll just start from the big and get to the, sorry, we're going to start on the small one and go big. So the smallest searching radius, you know, it's only summing the things within the center of each pixel, looking around. And so we can kind of see, yep, very quickly, these ones that we knew there were multiple points stacked on top of each other. They add more to the sum of the whole region. If we increase the search radius, it really affects, right? So from 1/16 of a mile to 1/4 mile, I believe that is 1/4 mile to 1/2 mile. And then, you know, all of these pixels are actually integers, but they're being painted using the single band PseudoColor in that style. So the Heatmap tool, I think, it's useful. Just be aware of what it's doing, and you know, it's pretty easy to just use the default, which, you know, I think always tends to look pretty good. If you run the default, yeah, be careful not to run it with the default, which was like 0.1 size pixel. You know, make it something thousand by something thousand, but not hundreds of thousands of pixels. Otherwise, your computer will crash. But the default, if we were to run that now, oopsie, that was pretty small. Try this again here. I want to try a bigger one. Let's try another 800. Run. And the nice thing about it is it does provide kind of a smoother cartographic expression. So I'm going to paste this style here again. So, you know, the idea that, well, really, you know, maybe this heat map does kind of provide the best sense that, well, this was the area of activity of kind of the incidents that happened that night. And it's just these pixels without explanation are just colors. They won't mean anything to a layperson. You know, they might mean something to you if you read up on what, you know, quartic, triangular, tri-weight, you know, the different the different algorithms, what they mean. The values might mean something to you then, but if you don't know what those are, then the uniform, you'll absolutely know what that means, and you can set your search radius to the size that kind of makes sense to you. So anyway, I think I'm going to leave it there for this video. That's the Heatmap tool and doing a join. I think they're both, I mean, well, you gotta know how to join, and the Heatmap tool is an interesting thing to use if you want to experiment with it. The next video, you know, I said I was going to do it in this one, but I'll wait to the next one, is I'm going to look at the time series tool. It's pretty useful, and I think that for this data in particular, it might prove to be something you want to look at. So one more video for kind of the in-queue analysis, and then I'll make one extra one about Mapbox before Wednesday. Okay, thanks.